Now we're going to look at evaluating the trig limits analytically. This is something we did back in Unit 7, and I know you're like, wait, where are you recording this video? Because what's that noise in the background? Sounds like a truck. Something really loud rolling. That's the unit circle. It is. Unit circle's back. Finally. And identities. My favorite. And yours. Identities. No more Usher, though. He left the building. I was going to bring in Master P. Little No Limit Studios, Little No Limit Soldiers, but that's not as good, and it's also not as appropriate. Let's get to it. All right, evaluating trig limits analytically. I want you to try these on your own. Pause the video. Find the limit as x goes to 0 of tangent of x, the limit as x goes to pi of x cosine x, and the limit as x goes to 0 of sine squared x. Pause. I'm pausing. We're ready to check. Hopefully you got that the tan of the limit as x goes to 0 of tangent of x is 0 because we can do direct substitution, and the tangent of 0 is 0 from the unit circle. The limit as x goes to pi of x cosine x is pi cosine pi. What's the cosine of pi? Unit circle, -1. Very good. So this becomes negative pi. The limit as x goes to 0 of sine squared x equals sine squared of 0. What is the sine of 0? Sine of 0 is 0. 0 squared is 0. All right, so we did direct substitution there for all three of those. Remember, that is our go-to analytical technique. Always try direct substitution first. But what if we try direct substitution? And what do we get here? We get 0 over 0. That is one of our indeterminate forms. However, we've actually seen this function, so we know what the limit is because we spent a lot of time with this in Unit 7. This was one of our examples for the squeeze theorem. I actually gave you a proof of this limit. It was on the website. We didn't go over it in class, but I told you to look at it. But I give you a proof of this limit using the squeeze theorem. And then also we looked at it graphically. And clearly I can see that on the graph, it looks as if from the left and from the right, it is approaching a height of 1. So I know that the limit is not indeterminate. It actually has a value, and that value is 1. Now this limit, and I talked about this a little bit back in Unit 7, but now it's going to be crucial. You need to memorize this. You're not always going to have a calculator. I know, sad. But from this limit, the limit as x goes to 0 of sine of x over x equals 1, we can find a lot of other trig limits. So you are going to want to memorize this limit and then use this to evaluate other limits. Here's our first example. So this was a problem on one of the reviews, I believe, in Unit 7. But using this limit, I want you to try to prove, so I'm telling you the limit as x goes to 0 of 1 minus cosine of x over x is 0. I want you to try to prove that using analytical techniques. I would recommend some trig identities, and also this is going to come up within the problem. So I want you to pause the video, try that, unpause when you're ready to check. All right, so we got 0, but we knew that. How do we get that though? So if I take the limit as x goes to 0 of 1 minus cosine x over x, and I multiply it by the conjugate of the numerator, 1 plus cosine of x over 1 plus cosine of x. One thing I didn't point out, so if we tried direct substitution right away, we would get an indeterminate form. I apologize, I didn't speak about that. I just did now, so there you go. Multiply out the numerator, I get 1 minus cosine squared x. Do not multiply out the denominator. So I get x times 1 plus cosine of x. But wait a minute, hold up, Pythagorean identity, I see you. 1 minus cosine squared of x is sine squared of x. So the limit as x goes to 0, sine squared of x over x times 1 plus cosine of x. Now, remember I kept emphasizing, we want sine of x over x, so I'm going to take the sine squared, and I'm going to think of it as sine of x times sine of x, and I'm just going to group these products and quotients how I want them. So I'm going to evaluate the limit as x goes to 0 of sine of x over x times sine of x over 1 plus cosine of x. Now at this point, I could have even gone a step further and separated this into two different limits as x goes to 0, because we can do that when we have multiplication. Remember, if you are taking the limit of the product of two functions, it would be the same as the product of the limit of each function individually. But in this case, I just evaluated each limit at this point, or each product at this point, the limit of each product. So the limit as x goes to 0 of sine of x over x is 1. I know that because I've memorized it. I love it. And then the limit as x goes to 0 of sine of x over 1 plus cosine of x, well, I can just do direct substitution. What is the sine of 0? The sine of 0 is 0. What is the cosine of 0? It's 1. What is 0 over 1 plus 1? That's 0. What is 0 times 1? Also 0. So I want you to try this one now. What is the limit as x goes to 0 of tangent of x over sine of x? Notice that if we try direct substitution, we get indeterminate form. So I want you to try this. Pause the video. Unpause when you're ready to check. All right, so here we should end up with 1 as our answer right there. How do we get that? Well, again, if we try direct substitution right away, we get indeterminate form. So what can I do? Quotient identity. Another fantastic identity. It's awesome how these are coming back up. Next thing you know, we're going to be verifying trig identities, right? Anyway, I digress. Getting a little excited there. So I get sine of x over cosine of x over sine of x over 1. Anytime I have division of fractions, multiply by the reciprocal of the denominator. So I multiplied the numerator and denominator. I didn't actually write that step out. I'll show you that. So I multiplied by 1 over sine x and 1 over sine x. Those go away. And now I'm left with sine x over cosine x times 1 over sine x. And again, now those go away. So we're left with 1 over cosine x. Do direct substitution. What's the cosine of 0? It's 1. Nice work. Moving on. Try the limit as x goes to 0 of tangent of x over x. And if you get really ambitious, try the limit as x goes to 0 of sine of 2x over x. Pause the video. Do this one at least. Unpause when you're ready to check. All right, so for the first one here, we should get 1 as an answer. How do we do that? Well, again, if I try direct substitution, I get 0 over 0 indeterminate form. What do? Well, I went to my quotient identity again because I know that well, two things. One, working in terms of sine and cosine is usually, not always, but usually easier. And two, I know my special trig limit of the limit as x goes to 0 of sine of x over x is 1. With that said, although this hasn't come up in any other examples, this is another one that you're probably going to want to memorize. And by probably I mean you're going to want to memorize. So you definitely want to know the limit as x goes to 0 of sine of x over x equals 1. And you most likely want to know the limit as x goes to 0 of 1 minus cosine of x over x is 0. Because using these two identities, you can evaluate almost any trig limit analytically. So back to what we did here. Limit as x goes to 0 of sine of x over cosine of x over 1. Multiply the numerator and denominator by the reciprocal of the denominator. So this becomes the limit as x goes to 0 of sine of x over cosine of x times 1 over x. Now, again, as I did before, I grouped the products and quotients in the groupings that I liked that are going to help me. So I rewrote this as the limit as x goes to 0 of sine of x over x times 1 over cosine of x. Now I can evaluate each one of these pieces. The limit as x goes to 0 of sine of x over x is 1. If I do direct substitution here, the cosine of 0 is 1. So 1 over 1 is 1. 1 times 1 is also 1. Okay, next one here. If you didn't already try this, I'm going to give you a couple of hints. So when we use our limit of the limit as x goes to 0 of sine of x over x equals 1, I want to emphasize that it does not have to be x. This doesn't have to be x, and neither does this. But what has to happen is they have to be the same. Okay, so it doesn't have to be x, but it has to be the same. So thinking about that, I want you to try and see if you can evaluate the limit as x goes to 0 of sine of the sine of 2x over x. Notice that this is not right here. This is not multiplication. This is the sine of 2x. Okay. Pause the video. Try that on your own. Unpause when you're ready to check. All right, so here we end up with an answer of 2. Well, what did I do? Well, again, direct substitution gives me indeterminate form. So I multiplied the numerator and denominator by 2 sine of 2x. Okay? Then from there, I grouped. And by grouping, remember, I guess maybe grouping is not the right word. I'm not like factoring by grouping. I'm just rearranging things because everything is multiplication. So I'm rearranging it in the order that I want so that I can see what goes nicely together. So for instance, this sine of 2x, this 2, and this x are this group here. Okay? The 2, so let's use a different color. Okay. The 2 right here, that's just that 2. I just put that in front because that's not going with anything else. And then let's use this maybe. Then this sine of 2x and this sine of 2x become this. Because again, this is what I was trying to emphasize. The sine, like think of it this way, sine of thing over thing. Okay, that thing happens to be a trig function also, but our limit still holds true that the sine of this over itself will equal 1. And the limit as x goes to 0 of that. So then I have 2 times the limit as x goes to 0 of sine of 2x over 2x. So again, since those are the same, the limit is 1. And then I have sine of 2x over the sine of 2x. Since those are the same, the limit is 1. So 2 times 1 times 1 is 2. All right, last one. Try this on your own. Pause the video. Unpause when you're to check. All right, this one we can do direct substitution. Hopefully that's what you did. Just plug in pi halves. Sine of pi halves is 1. Unit circle, x is just pi halves. So 1 over pi halves is 2 over pi. Fantastic. Don't forget about direct substitution. Always try that first. Okay, our conclusion. We want to know our special trig limits. This right here, limit as x goes to 0 of sine of x over x equals 1. You need to know that. You need to memorize it. Limit as x goes to 0 of 1 minus cosine of x over x equals 0. Also know and memorize that as well. If you don't, you're going to have to use this and the technique that we did before to figure this out. Make sure you know your trig identities. They're going to come back. Make sure you know your unit circle. Never went away. I know. Every week, you got to get a new seat. Evaluating trig limits analytically. Always try direct substitution first. If direct substitution doesn't work, try some trig identities. If those don't work, try to create one or both of the special trig limits, and that could be in a combination with using trig identities. If none of those techniques work, then you might have to do it numerically or graphically.